This is Mrs. Melcher here with another great presentation about the lesson that you're learning right now in advanced chemistry. Alright, as you can see at the top, it's section 22.5, but it's actually 23.5. This section is on polymers, and I have it on a PowerPoint because I thought it would be easier for you to see and understand rather than me writing it on the board and going through it. Plus, if you have any questions, they can be explained hopefully through this presentation. This is a presentation from your book, Chemistry, Matter, and Change. Here's the vocabulary that you'll find in this section. If you're confused at any time, feel free to write down questions on a notebook. You can write them in the comments, or you can let me know when you get back on what's going on. You can also read this section too. Alright, so section 23.5 is on polymers. Now polymers, they have a lot to do with hydrocarbons, like we've been talking about in this whole chapter and the last chapter. And they're just molecules consisting of repeating units over and over again. You'll find carbons, you'll find hydrogens, carbons, hydrogens, carbon, hydrogens repeated. There are also some other organic elements that you'll find within there too, like the nitrogen and the oxygen. If you had a chance to do it before you left, you'll remember that the glue lab was something that represents a polymer. And if not, the slime lab that we did at the beginning of the chapter is also a polymer lab too. Polymers have become very important and needed in our society, especially at the beginning, the 1900s, which is the 20th century. There were a lot of polymers that started coming out that we use often today, rubber in tires and celluloid in lots of different synthetic materials. Sometimes even we use polymers in clothing. Alright, polymers, like I said, they're just repeating units. One unit repeated over and over and over again. CH, CH, CH. Well, the monomer is like it sounds, using the prefix mono, meaning one, and poly, meaning multiple. The monomer is just one molecule where the polymer is made of. So the monomer is the repeated unit over and over again. Monomer meaning just the one, and polymer meaning many. So it's the one that's stuck together, repeated over and over and over again. One thing that you can do is you can make a polymerization reaction, which is just where those 1, 1, 1, 1 units are bonded together to make that polymer. So when you took the glue and the borax, stuck them together, that's a sort of reaction that performs and makes this polymer that acts in kind of a crazy way. That's called a polymerization reaction. And when you're adding the two together, you'll find addition polymerization, where the atoms that are present are retained into a product. So everything that you start with becomes a polymer in addition polymerization. You may remember these words from your vocabulary. Alright, here's some examples of where polymers are made. You'll see that polyvinyl chloride. It's commonly known as PVC, which is found in PVC pipes that are used in home improvements all over the place. And the picture there of a hose is found in wrap, like plastic wrap, rain gear, siding for your house. It's all PVC. And so polyvinyl chloride, it's got the word poly, meaning multiple. It's got chloride, so you know there's going to be a chloride in it. And you'll see there on the top in brackets, that just shows you the monomer, so that's the first unit. It's got two carbons bonded together. Each of them have H's off it, and one has a chloride. Do you see that N at the bottom? That just means repeating unit. So the N represents any number. Could be N2, could be N3. It's a polymer, so the polymer has many, many units. Alright, going down to the second one, we see polyacrylonitrile. This is found in clothing, upholstery, and carpeting. Definitely a lot of carpeting. You can see and feel that it doesn't feel that soft. It feels sort of plasticky. And that's the monomer right there. Again, you see that little N at the bottom outside the brackets representing multiple. we've got two single bonded carbons with their hydrogens, and those will bond as long as they need in their polymer. But off the second carbon is a carbon with a triple bond to an N. So you'll see carbon-carbon, and then the second monomer will be carbon-carbon with that CN from the bottom of it. And the C in the end is called the nitrile group. All right, then we've got polyvinyl idene, which is found in food wrap and fabrics. Oh, polyvinyl idene chloride, pardon me. And you can see how that's sort of similar to the polyvinyl chloride, has the chloride group in it too. The only difference is that in the polyvinyl chloride, I see they have it set up a little bit differently, so it might be a little bit confusing. But the PVC on top has just one chloride group, and the PVC on the bottom has two chloride groups. That's why they call it diene. Except for it looks like they have the polyvinyl diene chloride, they have it mixed up. So it should say diene, not idene. Polyvinyl diene chloride. Makes sense. Here's some more polymers that are common. Polymethyl methacrylate, which is found in glass, non-breakable glass like your glasses, lenses, windows, your car windshield, which is supposed to break very easily. And the monomer for that one is a lot more complicated than polyvinyl chloride and the other monomers that we previously looked at. Okay, we have the polypropylene, which is called PP. Sometimes you might see these on different plastics if you turn them over. It's pretty common. Beverage containers, it'll say PP on the bottom if you turn that over. Like a Coke can or a Coke bottle will say the PP on it. Different appliances are made out of this. That's a very simple monomer, not compared to that polymethyl methacrylate, which is very complicated. And then the polystyrene, which you'll find in your styrofoam and different things like that. You can see it has a benzene ring on it. It's pretty fascinating. And that's polymer. These things are all polymers, have repeating units. Those little ends at the bottom showing you that they can be repeated in any number of unit repeating. A couple more, we've got the PETE, the peat, commonly referred to as plastic, which is found in other bottles, tire cords, clothing. It's called polyethylene terephthalate. So you can see that has a benzene ring in it too. And it's got the ester group in it, the double bonded O with the O in the center, if you remember that's the ester group. And then on the bottom, polyurethane, found in cushions, waterproof coatings, things that you do not want to burn, do not want to get into the environment. There are a lot of different groups in there you can pick out that we've talked about in class. All right, condensation polymerization reactions are a little bit different than addition polymerization. This just takes place when you have two functional groups, and the word condensation, just like we talked about before, the condensation means that it takes water out of it. So if you can see with the adipic acid and the 1,6-diaminohexane, that the OH group and the H group are sticking together to make nylon, pretty common polymer, and the byproduct there is water. The N's just represent however many moles of water are there, and the M's representing however many monomers are stuck together. Condensation, polymerization. Polymers are very inexpensive, easy to make, so that's why they are so common in society. We have a lot of polymers with plastics, and they have a lot of different properties like melting point, boiling point, and all those sorts of things. They are very easy to mold. Just think about styrofoam and how you can almost even mold it with your hands if you do that thing with the upside down cup. They're easy to mold with plastics. You can melt that down and shape it into anything you want. So thermoplastic, those are the special type of polymers that can be melted and molded repeatedly into different shapes. Thermo, if you know your prefixes, thermo meaning heat, just heat it up, melt it down, and reshape it. Thermosetting with the setting and the plastic being the important part, the thermal setting, it means it can be molded the first time, but you can't actually remelt it down and make something else. So an example of this would be some certain plastics, just like thermoplastic is some other ones that can be repeatedly heated. Thermoplastic ones being like soda bottles, thermal setting ones being more like styrofoam. All right, pretty near and dear to my heart is recycling, as you all know. And if you look on the bottom of your water bottle or any other plastic that you have, you'll see these symbols telling you what to do, how to recycle. And recycling, like I said, is very important to me. Here are the different numbers, along with the things that we just talked about. We got PETE, the polyethylene terephthalate. We got the vinyl, the PP, polypropylene. You'll see a lot of these different things on the bottoms of your plastic containers. Number ones are usually fairly common. That's what you'll find your soda in, and then all these other ones too. I would encourage you to look at the bottom of your bottles when you're traveling and see if you can find any of these numbers. Okay, so that is the end of your unit for section 23.5. Here are a couple questions for you to review and ask yourself if you know what you're talking about. All right, smaller repeating units that make up a polymer are called monomers. Hopefully you got that one right. Second question before we move on and say goodbye. One way polymers are synthesized is through blank reactions. The correct answer is condensation. All right, hopefully you enjoyed this. Hopefully you learned a little bit. And if you have any more questions, please send them along to me, post them in the comments, or feel free to read your text. Thanks.